In this segment, we'll look at the inventory class and also some deeper issues in the use of the map class and of similar collection classes in other languages. Now, the inventory class, right here, contains two maps of inventory lots. The first, lots, is indexed or keyed by lot ID, an integer, and it allows lookup of any inventory lot. The second, which is stock, holds only inventory lots that aren't used up yet. And it's keyed by part name, a string, so that we can look up inventory lots that supply a given part. But, and here's the big point in the lecture, at the first part at least, stock's value type, as you can see, is not a simple inventory lot. It's a sorted set of inventory lots. Can a map have another collection as its value type? Sure, and nesting collections in this way is a powerful design tool. You can make maps of maps, lists of lists, maps of lists, and so forth, depending on your data needs. And this is a design principle that spans many languages, whether it's C++'s Boost and standard template libraries, or C#'s collections, or any other collection class library. The same nesting principles usually apply. Now, why would we want a sorted set of inventory lots as stock's value type? Because we can't have multiple entries with the same key. Maps require unique keys. And if there are several inventory lots of, well, say, Bolt, for instance, then we want to group them into a single map entry keyed by part name Bolt, and that'll be the sorted set of inventory lots under that key. Now, we want these inventory lots sorted in increasing order of costs, so we can use the cheapest ones first. That's the point of the sorted set. A sorted set keeps its contents in sorted order, in much the same way that a sorted map does. And there's the Java docs for sorted set that I'll have you be looking at. Now, it uses either the type's built-in comparator, if it has one, or an externally supplied comparator that's passed to the sorted set constructor. So question one for you to answer, which sorting strategy, the comparable or comparator, will we be using for our sorted set inventory lot? Which one do you think and why? Look at inventory lot, maybe even look at the code to see where we are initializing or creating our first sorted set, and you should be able to figure that out. So returning from a pause, inventory lot implements comparable, and recall that it does so using a cost comparison rule. So it's reasonable to expect that the sorted set would use the comparable interface to sort inventory lots by increasing order of cost. And question two, look up the sorted set Java doc that I showed you briefly a moment ago and write code that would retrieve from stock the sorted set for part Bolt, and then from that sorted set would get the cheapest inventory lot containing bolts. Assume both entries actually exist in their respective collections. There's no need to test for null, for instance. So you'd be expecting to get the sorted set for bolts via a get call on the map, and then in the sorted set here we have the first method that returns the first or lowest element currently in this set. So the whole answer would be stock.get on bolt, and that gets our sorted set, and then .first to get the inventory lot. Now, method add inventory lot, right here, adds a new inventory lot to the inventory. And you know enough about set and map collections to read the comments and the code here, and to then answer a couple of questions without further explanation. So the first question is, what do these lines right here, these two, accomplish, and why? And returning from a pause, there may or may not already be an entry in stock for the part supplied by ILT. Stock may or may not contain the part name as a key. And if there isn't an entry, then this code inserts an empty tree set of inventory lot in stock under the correct key. And this ensures that the get on the following line here won't return null. Okay, and then the next question. These lines here apparently add ILT to the sorted set associated with the part name. And there's the add call right there. But they don't do a put back into stock. So why is that not necessary? Recall a discussion from a segment or two ago on the fact that collections hold references. Maybe after some thought there, the get call doesn't remove the sorted set from stock, it just returns a reference to it. So the val.add call right here is adding ILT directly to the sorted set that is still in the stock map, not to a copy. Indeed, be sure you understand that no copies were made of ILT anywhere in the entire add inventory lot call. Inventory creates no inventory lots of its own. It just tracks and manages in its to map member data the inventory lots passed to it via add inventory lot. The fact that assignment of object references is shallow by default, that reference assignment doesn't make a copy, will become important in an upcoming segment when we find we must make deep copies of component objects in the catalog in order to properly track multiple orders of the same component. So moving on now to use part. Again, you know enough to read the entire use part function code without explanation. Now, please look it over and then answer this question. What small change to the use part code could we make to use the most expensive inventory lot first instead of the least expensive? And after a pause, it should be pretty clear, based on the earlier exercise that we did also, that if you just change first here to last, then you'll wind up getting the most expensive one instead of the least, and that's all it takes. So, the report usage method down here, well, it's not very long, does need a bit more explanation. It reports for each inventory lot which orders used it and how many parts they drew from it. Now, the outer loop should be obvious by now. It's iterating through all of the inventory lot IDs. The inner loop, however, takes some careful reading. It iterates through the collection returned by this expression right here. And before we take that expression apart, do recall that inventory lot maintains a map uses member that tracks the orders that use that inventory lot and the part count given to each order. So with that in mind, it looks like that what we have here is a get of an inventory lot and then a get uses on that to get that uses map, and then a entry set call on that sorted map of orders and integers. So what does entry set do? It returns a view or an adapter like key set, but entry set returns a set of map.entry objects, and these represent key value pairs from the map as opposed to just keys. Now, entry is a nested interface of map, though the Java docs list it separately from map. So look up the Java doc for map.entry in java.util and then answer this question. And actually, it's going to be 4 questions in one. First, map.entry is generified. What types go in the angle brackets after entry? Again, the docs will tell you this. Second, how do I get the key and the value of the pair that a map.entry represents? Third, what what types will those methods return, the ones that return the key and the value, what types will they return for the map entries in report lot usage, the ones in our expression? And fourth, can I use the map.entry to change the contents of its map in any way? And what way, if so? So answering the first of those questions, the K and V types are the key and the value types to be filled in the angle brackets. For instance, map.entry order, comma, integer. And then answering the second question, it is the get key and get value methods that return the key and the value from the map entry. And in report lot usage, they return a order and then a right there, an integer for the value, and then an order for the get key, respectively. So that's the answer to the third question. And then to the fourth question, you can see that set value does allow you to change the value of the pair in the map, the value associated with that key. So you can use a map.entry to do the same thing as a put, but you can't change the key that it represents. Now, with all that figured out, we can see that the inner loop here iterates ENT through all the map entries in a map of usage statistics, and then it uses the get key and the get value methods to print the number of units and the ID of the order for each usage statistic. And then one last question, well, okay, two questions. Does that code get the order usage stats even for inventory lots that are used up? Why? And does it report the inventory lots in any particular order? Again, why? And the answer is, yeah, it prints order usage statistics for used inventory lots, as it should, since they have the most usage stats, actually. Member lots is a map of all inventory lots. And they're reported in no particular order, because lots is a hash map, and its entries are ordered unpredictably by hash code.